right, so we'll be taking a deep dive into the blockchain architecture. And when we talk about the blockchain architecture, we're going to be seeing the two fundamental things that makes up the blockchain architecture, and we'll look at these things carefully. All right, so Nali Nathaniel, a blockchain engineer at Web3 Protocol Africa, powered by Guild Academy. You can reach me at Nanlinat. This is my Twitter handle, and this is Web3 Protocol Africa's Twitter handle. You can reach out to us, send us a DM. We'll be so happy to hear from you. All right, so this is what we're going to be looking at for today regarding the blockchain architecture. Two main layers of the Ethereum protocol. Two main layers of the Ethereum protocol. We're going to be looking at the execution layer, which is the state machine, and we're going to be seeing the consensus layer and how the execution layer and the consensus layer work together. So the reason why this particular workshop is important is because as we progress with our workshop, we'll be diving into each client, and so it is important for us to have an overview regarding the workflow from the execution layer to the consensus layer. That's the architecturing of the blockchain. And in our last contact, we've established that the blockchain protocol that we'll be making emphasis on is the Ethereum blockchain protocol. All right, so two main layers of the Ethereum protocols. The two main layers of the Ethereum protocol, what are they? So basically, we have the execution layer and we have the consensus layer. The execution layer handles transactions, smart contract logic, and state. And then we have the consensus layer ensures network agreement, block finality, and validators coordination. So let me explain what this is now. So when it comes to Ethereum, we have applications that are running on the blockchain. For instance, you want to do a transaction. The part of the transaction that handles when I say transaction now, I mean you want to send some amount of it to a friend. That's an example of a transaction. So that the part of the blockchain, the part of the Ethereum that handles that transaction is the execution layer. And the reason why it handles transaction is because the smart contracts we have, excuse me, smart contracts are executed on the execution layer. So every smart contract logic we see today, they find their roots on the execution layer. We're going to be seeing these things as we advance further, but what I want you to just note from this first slide is that um, the two main layer of the Ethereum protocol, the two main layer of the Ethereum protocol is the execution layer and the consensus layer. And the execution layer handles transactions, smart contract, and state. And then and then we have the consensus layer that ensures network agreement, block finality, and validators coordination. As we continue, like I said, I will explain all of these things as we go further. But this is what I want us to understand. I repeat again, is that the two major layers, the two major components of the Ethereum protocol is the execution layer and the consensus layer. These are the two components that makes up Ethereum what it is today. If we're talking about Ethereum, there won't be Ethereum if there are no execution layer and consensus layer. All right, looking into the state machine, I call it, yeah, the state machine, the execution layer now. All right, so think of the execution layer as the application engine of the blockchain. So it processes transaction and changes the blockchain state accordingly. So what that is telling you is when a transaction is running on the Ethereum blockchain, the part where the transaction is processed is on the execution layer, and part of the execution layer that handles the processing of transaction, especially when it comes to implementing the smart contract logic, we have the EVM, the Ethereum virtual machine, execute the smart contract logic. So as we advance, as we continue to explore more technical things when it comes to the execution layer in our subsequent workshop, you discover that every smart contract you see on the blockchain has an account. Apart from your external own accounts, which an average developer should know, like your MetaMask and all of these wallets, they are external own accounts. So your smart contract has its own account. So all of this logic are processed from the Ethereum virtual machine. And then this account are stored in what we call the state trie, stores account balances, contract code, and storage. So there are certain smart contract logics that are not just stored in the memory. As this thing I'm saying, they may not be within the scope because the goal of this workshop is for we to have a general overview of the architecture of the Ethereum protocol. When we start diving deep into the execution layer, we're going to be chopping it different component by component. So maybe a workshop we can take the Ethereum virtual machine and we'll see all of the way you can store data in the Ethereum virtual machine. And then we'll be seeing things like the memory, we're going to be seeing things like the stack, and then we're going to be seeing things like storage. So what we are seeing from here is that the part of the Ethereum protocol that handles your account balances, handles your contract code and storage is the state trie, which is found within the execution layer. And we also have what we call the mempool. So have you not noticed something when, let's say, for instance, somebody is sending 2 ETH to a friend and you actually click the button send, but somehow your friend is yet to receive it and it's showing you pending. Now, that transaction is actually stored in a place we call the meme pool. It's called the waiting room of transactions. So, for instance, now maybe there is traffic in the network. So these are instances where transactions are stored in the meme pool before they are called by the consensus, before the consensus client will lay demands on those transactions or validations. So transactions are temporarily stored on the meme pool, so they call them pending transactions. So all of this logic now, they are found within the execution client. And then example of the execution clients we have today is we have get. This is an implementation of the execution client with the Go programming language. We have Nethermind, we have Eragon and Red. So all of these are unique implementations of the execution client. This is very important. We know this. Very important that the three major component of the execution client, three major component of the execution client. There are other components, like I said, as we dive deep, will be when we start to expand this state trie, you discover that there are many things within it. There are many concepts within the state trie. When we start to explore the meme pool, you discover that there are many logics within the meme pool. But what we need to understand is, I rephrase, is that there are two major components of the Ethereum protocol. We have the execution client and the consensus client. And what we are now seeing is that the execution client contains the EVM, that's the Ethereum virtual machine. It contains state trie, the meme pool. An example of such clients are the Get, the Nethermind, the Eragon, and the Red. Very important. So what is the responsibility, or what are the responsibilities of the execution client? Why do we need an execution client? So they accept and simulate blocks, verify transactions are valid, compute state transition. When we say verified transactions are valid. Now, the basic thing it checks. Okay. I don't want to fool us with many informations in this workshop. I just want us to be taking these things gradually. In one of our workshop, we're going to be looking at block verification within the execution layer, and you're going to be seeing these things very, very well. That for a transaction to click successful, remember we said something about a pending transaction stored on the meme pool. Now, for that transaction to actually show you that sent but waiting, for that transaction to actually go as sent and yet be waiting, is that there are certain criteria that the execution layer must have to allow that transaction go to. So some of the criteria that the execution client will use to verify a transaction to be valid within a block is that you don't send the amount of it you don't have. You can't send the amount of it you don't have. An example is that you can't say you want to send 2 ETH to Alice and then you only have 0.5 ETH. That transaction is going to go as fail. So even before the transaction will be processed and validated by called out from the meme pool and all of those processes, before it actually goes as successful, the execution client will have to check the validity of that transaction. So what it does is that it checks the person who is trying to perform this transaction. Does he have the required criteria to make this transaction possible? So the execution client will check, it will check the validity of that transaction. So if the person who is trying to execute the transaction does not have the adequate amount of it for that transaction to happen, it returns false. It returns a failed transaction. And one of that criteria it checks is that the person who is doing that transaction is actually the right person doing it. So that we will not have people who are scamming other people with their wallets. And this is where the whole concept of private key and public key comes in. So all of this logic are found within the execution client. So, like I said in the previous slides, I said all of these logics are within a concept. And when we start to dive deep into understanding the execution client, we will now start to see different aspects of these things and how they are applicable to protocol engineering. And then one other responsibility of the execution client is it computes state transitions. Like we said earlier on, it stores accounts, balances, contract, the account contracts, and all of these storages. Anything that has to do with storing data, it's within the power of the execution client to do that. And then it emits execution payload for new blocks. When we get to the consensus client, you understand what exactly it means for the execution layer to emit payloads. You understand that. So remember that there are a number of transactions that are stored within the beam pool, right? Yes. And for those transactions to move to the next phase, the consensus layer assess those transactions in form of payload. Yes. So what I want us to understand is that there are responsibilities within the Ethereum protocols. And the thing we're seeing now is the responsibility of the execution layer. This is very important because you cannot write any code. You can't build, you can't write anything when you don't understand the logic. You can't. You can't write a code logic that describes block validation within the execution layer when you don't understand the entire logic. So that's the reason why this is very important. All right, looking into the consensus layer now. All right, so the consensus layer is responsible for agreeing on the canonical chain and preventing fork. So what the consensus layer does is that it ensures that each each block that is to be added to the network is obeying certain rule and regulation, such that when those rules are not obeyed, that's when we start to have things like fork. So the consensus layer is responsible for preventing forks. When we advance further deeply into the consensus layer, we will see all of these logics. And then the consensus layer uses the validators and staking, that's the proof of stake. Now, the component of the consensus layer, we have the beacon chain, which is the core coordination layer, and then we have the finality gadget. We have the fork choice rule. Now, this finality gadget helps us attain finality within the as a rule in the consensus layer. The part of the blockchain, the reason why we are saying the blockchain is immutable, when something is deployed there, you can't change it. The reason why these things are possible is because of the function of the finality gadget. So the part of the consensus layer responsible for block finality is the Gaspar FFG. That's the work of this guy, this component here. And like I said, as we continue to dive strictly just on the consensus layer, we will see all of these things. And I promise to show you a code base. Yes, and we'll do a walkthrough seeing all of these things together. So the part of the consensus layer again responsible for preventing fork. We don't have simultaneous chains running in a network. This is literally what we call fork. We don't have two different chains of blocks added to the network. To prevent that, the part of the consensus layer that does that is the LMD ghost, the fork choice rule. It's very important to understand this. So some of the example of the consensus client we have is Lighthouse, Prism, TechU, Nimbus, and Lodestar. All of these are unique implementation of the consensus layer. As we dive deep into the consensus layer, we'll look at all of these things, the beacon chain, we'll look at the finality gadget, we'll see fork choice rule. Although for beacon chain, there is a project going on. I will use this medium to advertise the project to those who are curious to want to contribute to the project. Is a beam. We want to transition the consensus layer from using beacon chain to beam chain, and there are different implementations of that logic. We have those who are implementing the beam chain consensus layer with the Zim programming language. I think they call their client the Zim chain. Yes, the Zim chain. It is a Zig implementation of the beam chain consensus layer. And we also have the beam, BEAM, the rim chain, sorry. So the rim chain now is the Rust implementation of the beam chain consensus layer. So we're trying to see how we would transition from using the beacon chain consensus layer to a beam chain consensus layer. A lot is going to be happening within the blockchain space, and that's the reason why workshops like this are very important to equip developers who are curious to dive into protocol engineering. All right, so what is the responsibility of the consensus layer? What is the responsibility of the consensus layer? One of the responsibility of the consensus layer, it selects proposers and attesters. It selects proposers and attesters. These proposers are validators. Yes, you can see in the next line, validators validates execution payload from execution client. So remember what I said within the context of the execution layer. I told you that the execution layer provides payloads to the consensus layer. Yes, so for the transactions that are impending within the mempool to transit to the next phase of the whole process of the transaction lifecycle, what the validator will receive from the execution layer is the pending transaction in form of its payload. So the execution layer presents it in a payload, and then the validators propose and attest. So when I'm trying to see how these things will be very easy for us. When I start talking about validators now, we may not really get the grasp of what I'm trying to point out here. But let me just say it, maybe just say it. Yeah, so the validators now, what the consensus layer will do is that they choose a validator who will propose a new block, and a new block is going to be proposed by a validator. Now, what that validator will do is that it gets the pending transactions in payload, yes, and those transactions are to be added to the block that this validator is proposing. And then after being proposed, other validators will now attest. They will vote to see the authenticity of the transactions that were added by the proposer. Yes. And then the next responsibility of the consensus layer is it aggregates validators attestation. It aggregates validators attestation. So after the transactions are stored within a block by a validator, by a proposer rather, other validators will now attest to that transactions in that block. So they will check the authenticity of that transaction. The consensus layer will now aggregate to see the number of validators who have attested to that block, to see the uniqueness. So the number, if you have more proposers, validators who had attest to the validity of the proposed block, the more that block is seen as legit when it is to be added to the block, to the blockchain network. Yes. And then the consensus layer also ensures finality and liveness. We spoke about this thing where we spoke about the finality gadget, the Gaspar FFG. So the consensus layer is responsible for finality. This finality is a logic where anything that is deployed on the blockchain cannot be changed, cannot be removed there, it's there forever. All right. So how does these guys work together? I mean, even from this little workshop, we've seen the flow already, but a quick one now. How does the execution layer and the consensus layer work together? A quick one. All right. So the consensus layer, which happens to be now the beacon chain, it picks one validator to be the block proposer, like we've said earlier on. So the consensus layer, which happens to be the beacon chain, don't worry, as we explore this, you will see how the consensus layer decides who is going to propose a new block within the validators. I mean, this thing is just amazing. It's just amazing. And then the next thing is now this proposer contacts the execution layer. Look at the flow. The consensus layer picks one validator to propose a new block. Now, the proposer with his new block contacts the execution layer, like the get or our red client, and say, hey, give me a list of transactions and calculate the results. So he gives me a list of transactions. Now, where are these transactions stored? These transactions, before the proposer asks the execution layer to give him, these transactions are stored within the mempool. We're going to be seeing how I'm going to show you the code, how these things are stored and how these things work. And then now the execution layer builds an execution payload. So when the proposer contacts the execution layer demanding for a list of transactions that are impending, the execution layer now will now build an execution payload. So those transactions, they are built in a format, we call it a payload, right? Now this payload now includes the transaction, people sending it, calling smart contracts and etc. So all of these transactions, all of the transactions happening within the blockchain, you sending some amount of it to your friend. All of these transactions which were stored within the mempool, the execution layer now will now build them into an execution payload because a proposer is making demands from those transactions. So your execution layer will build those pending transactions into execution payloads. And some of those transactions includes people sending their hits, calling other smart contracts, and then it also involves gas usage, updated account balances, and contract states. It also contains a special hash that represents the new state called the state root. You get it? We said the execution layer also handles storage. When we look at these things deeply, we'll be seeing all of these things. So what we are seeing here is that the execution layer builds a list of the transactions into an execution payload and then presents it to the proposer. All right. Now the proposer builds the full block. Builds the full block. This is what it does. The proposer wraps this execution payload inside a bigger block called a beacon block. So the block that is added to the network is actually a beacon block, not just a block that is tested from the execution layer. Remember, I told you that the execution layer also have a rule to see that a transaction goes successfully. Yes. So for a transaction to be added to the network, it has to be a beacon block. So the proposer builds the full block. The proposer wraps the execution payload inside a bigger block called a beacon block. Now this full block now contains, these full blocks now contain the consensus info. Who is the proposer of this new block? When did he propose this new block? When is a new block added to the network? And all of these ideas, when we look at these things deeply, we'll see. So the beacon block that is to be added to the network contains the consensus info and the execution info. The execution info involves all the transactions and state updates. All the transactions and state updates. So there is details within the consensus layer and there are details within the execution layer. So the beacon block contains the list of all the informations within the consensus and the execution layer. All right. So the proposer sends the new block to other validators in the network. So after building this up to a full node, to a full block, rather called the beacon block, the proposer sends the new block with the information from the consensus and the execution client. So the proposer sends the new block to other validators in the network, and each validator check two things. We are seeing the role of a validator. When we start to do a live running of node, I'll be showing you these things, how validators are going to be checking the authenticity of a new block that is to be added to the blockchain network. So the proposer sends the new block to other validators in the network, and each validator checks two things. This is what every validator within the blockchain protocol checks. The first thing it checks, it checks the consensus layer part. What was this block proposed at the right time by the right validator? So this is now when we now start talking about slashing. when it comes to running nodes. When a validator sleeps or his computer sleeps and he's not proposing this block at the right time. So these are the things that the proposers, other validators will check with the proposer's block. So when you are proposing a block, the block is going to contain when you are proposing the new block. Are you proposing the block the right time or you went to sleep? So the validators will check the details of the consensus layer part. And some of the details in the consensus layer part they're going to check is, was this block proposed at the right time by the right validator? And the consensus, the execution layer part is, are all the transactions valid? Does the state match? So these are the logic that the validators are going to be checking for the beacon block that is to be added within the Ethereum network. And then if it's valid, they vote attest. That's the attest. So if they've checked all the criteria to that defines the authenticity of a block to be added to the network, they vote. So every validator has a right to vote for the authenticity of a block that is to be added to the blockchain network. So when they see that this block is genuine, they see that the block is actually lit, they vote for the authenticity of that block. We call it to attest, attestation, and they get rewarded for doing that actually. So that's the reason how that's how block validators, people who run node are making their money. The more you attest, the more you vote, the more you make money. If you as a validator, you don't attest, you don't vote for the authenticity of a block, you also be slashed. So all of these things are very important. All right. So the next thing is, um, once enough validators agree, the block is finalized. At this point, when the block is finalized, there's nothing you can do about it. It's there. And that's the reason why we have transactions that are on the blockchain network for over um, 10 to 15 years. They are still there. All right. Do we have any question with the architecture of the blockchain protocol, specifically the Ethereum protocol? Do we have a question? All right. If you have any other question, maybe in your personal research, and you discover that there are aspects where you don't really have clarity on, you can go to the Discord channel and you can drop your question on the Discord channel, and we'll do well to respond to it. If you have any further questions, or maybe doing your own personal research and you want to have a clarity regarding a concept, you can drop your questions there. All right. So this will be the end of the workshop. Like I said, if you have any question, you can drop it on the Discord channel, or you can reach out to me on Twitter, and I'll be delighted to respond to you. All right. See you in the next workshop. See you next week.